Hello, welcome to the 11th webinar of the Climate Toolkit. I'm Richard Piacentini, President and CEO for Phipps Conservatory and Botanical Gardens. It's a pleasure to have you all with us. Our conversation today will explore the topic of nature-based solutions as a strategy for carbon sequestration and climate resiliency. Nature-based solutions are widely recognized as a critical component for reducing our global emissions. In fact, the IPCC's latest synthesis report found that nature-based solutions are among the top 5 most effective strategies for reducing carbon emissions and can contribute as much as 30% of the mitigation necessary to stabilize the climate crisis by 2050. At heart, nature-based solutions leverage the power of nature and biodiverse ecosystems to sequester carbon, restore healthy soils, and green our cities. During the next hour, our guests from Duke Farms, the California Academy of Sciences, and the Wild Center will present 3 case studies focusing on an array of nature-based solutions being utilized on their campuses and in their communities. And now, I'd like to send it over to Andrew Lample, Climate Toolkit Manager, who will moderate our discussion and introduce our guest speakers.
Thanks so much, Richard. Before we get started, I am very pleased to report that the Climate Toolkit is now 133 institutions serving more than 68.3 million annual visitors in 14 different countries across the globe. We are thrilled to see such momentum and growth of this project. Please consider adding your institution to the Toolkit network if you haven't done so already. And I'm placing the entry form link in the chat right now. As the presentation begins, you are welcome to use the Zoom chat function to enter questions, which we will answer after the talks have concluded. And now, I'd like to begin the webinar with our first speaker, John Wager, Deputy Executive Director, Operations and Sustainability at Duke Farms in Hillsborough, New Jersey. John?
Hey, everyone. Just going to share my screen here. All right, y'all see that? We good? And it's not in presentation mode, hopefully?
Okay. Everything looks good.
So my name is John Wager, as Andrew said. I am Deputy Executive Director of Operations and Sustainability at Duke Farms. And we are a center of the Doris Duke Foundation. At the Doris Duke Foundation, our mission is really to build a more creative, equitable, and sustainable future. And I'm going to talk a little bit today about our way of framing this idea of nature-based solutions for climate change within all of our operations of our foundation. And then get into some specific research we're doing here at Duke Farms that hopefully will inform a lot of what we all want to do with nature-based solutions for climate change. So what do I mean by nature positive, carbon negative, and what are the points I'm going to go over today? Number one, I think it's really important for all of us to understand that we need to drive emissions to zero and do natural climate solutions. It's not enough just to do natural climate solutions. I think we all know this, but our institution should be using the Climate Toolkit, right? Comparing notes with folks and driving our carbon emissions down. At the same time, figuring out how we can utilize natural climate solutions. Now, why do we want to use natural climate solutions? Because photosynthesis is the only way we know at scale to remove carbon dioxide from the atmosphere. Another kind of obvious thing for all of us, right? And it can, as Richard said at the beginning, draw down, 20 to 30% of annual emissions. Now, the math just doesn't really work out because if you think about it, we've already blown past sort of the sustainable amount of carbon dioxide in the atmosphere, greenhouse gas in the atmosphere, to not see a lot of climate change. So again, we really need to do both. I think we need to highlight we need to do both, and we need to do both at the same time. And then the final point, which is also really important with natural climate solutions, and you'll see a little bit of these issues we're facing here at Duke Farms, is that not all nature conservation can or should be maximized for climate sequestration. We should preserve nature for biodiversity's sake, right? We should be preserving plants and animals beyond just for their ability to photosynthesize. And so that's kind of, those are sort of the concepts we think about here at Duke Farms, when we talk about being nature positive and carbon negative. So what is Duke Farms? We're 2,700 acres. We're located about 35 miles west of New York City. We're the former estate of J.B. Duke of Duke University fame, and then Doris Duke, who was a benefactor of the Doris Duke Foundation. As far as size, 2,700 acres. So this is kind of Central Park superimposed, as well as Disneyland. So we're a big property, especially for central New Jersey, right? And we're at a scale we think that matters in a very urban environment. If you look on this aerial, you can kind of see the development to the east and to the west. So I think, sort of given that scale and our interest in natural lands management and our benefactors' wishes, we've developed this property to be a public entity and a model and leader in environmental stewardship. So some property highlights. These are some of the things that visitors come and see. We get about 200,000 visitors a year. So we have about 100 buildings on the property. We have a pretty extensive infrastructure. I'll show you a little bit about that in a second. But it's a very, it's a place people come to enjoy nature. And we do things like manage the landscape very sustainably. So don't use herbicides and pesticides and things like that. And really try to demonstrate sustainability in action to those visitors. As far as habitats on the property, this is a little bit of a snapshot of some of the habitats. We have about 800 acres of forest, more than 450 acres of grasslands, shrublands, open water. We have a lot of habitats along the Raritan River. And of course, all of the creatures, the native creatures that like these habitats. We also have a pretty extensive working landscape here. We have hundreds of acres of pasture, and we raise pasture-raised beef. You may wonder why an organization with a mission for environmental sustainability has beef cattle. The answer is we feel like working landscapes are really key in addressing the biodiversity crisis and in climate change as well. And specifically at Duke Farms, we have a whole suite of endangered grassland birds that pretty much only occur here in New Jersey. So all these species have been extirpated. So there are a bunch of sparrows. You can see the kestrel there, upland sandpiper, which actually has been extirpated, unfortunately, the bird standing in the middle. So again, we're doing what we call agroecology. So we're using our cattle to create sort of a demonstration and also actually working on markets in the region to work with farmers to convert regular row crops to permanent pasture. Obviously, there's a huge uplift there. And then there is an uplift in carbon capacity of the soil as well. So we have this big agroecology working landscape element of what we do. So I want to take a step back, talk really quickly about the energy work we're doing, because it really instructs a lot of the work we're doing on carbon sequestration. The energy we started in 2015, and it all started with a baseline. So we have an energy baseline, and I'm going to talk about the carbon sequestration baseline we have. So we developed a model where we model all of our operational carbon footprint, so all the carbon we use in a year. And we've actually sort of simplified this and are hoping to be able to create a product that all of our institutions can use to figure out where we're using energy and then where we can optimize reductions in our carbon footprint. So this is a map here showing all of our buildings, whether it connects to our internal medium high voltage circuit, which we control, or the external grid, which our utility is called PSE&G. So this was like, creating the baseline, figuring out where we're at. And it was really important. We actually did this even before we came up with goals, which are next. So we created this energy baseline, and then we came up with a bunch of goals. And so this is called our Natural Systems Energy Plan. And again, you need, I think we need to look at the energy reduction stuff in our institutions and also sort of the carbon sequestration angle of things. And so this is what this plan is. So the first two goals are related to energy, and the other two goals are related to emissions we don't control, Scope 3 emissions, and carbon negativity. That is, how do we manage our lands for additional carbon sequestration? And then we have specific things we're doing. Again, having this energy baseline, understanding what our long-term capital and operating budgets are, we're able to really optimize how we can reduce our carbon footprint as quickly as possible with our energy use. So I'm going to jump now to some of the restoration activity that we've done. So we converted hundreds of acres of turf lawn to meadow. This is before we did anything with a carbon baseline. This is just for improving wildlife habitat. So this is even before we were talking about natural climate solutions. So here's an example. This was called the Great Lawn, and then we converted it to a Great Meadow. And then we've done a lot of wetlands restoration as well. So this is an area where we worked with the Natural Resources Conservation Service and broke up tile drains in previously drained soils and previously drained soils for agriculture. There are these drains that would drain off all the water, and then created like micro topography and little ponds and stuff. So this is before, this is after. You can see the great blue heron there. So we've done a tremendous amount of restoration. The other thing we've done is a lot of forest restoration. Here in New Jersey, we have a huge problem with overabundant white-tailed deer. So we have a very sophisticated white-tailed deer management program where we've been able to manage deer at ecological carrying capacity rather than sort of social carrying capacity. So we see forest regeneration here. We've done a lot of enhancing forest regeneration. The trees are regenerating. We're doing a lot with like shrub replanting, which don't seem to be regenerating as much. So the point is we've done all this restoration outside of natural climate solutions. And in total, we've done about, we've done hundreds of acres of wetlands restoration, grassland restoration, afforestation, planted hundreds of thousands of plants over the years, and converted the turf grass to native meadows, as I mentioned before. So natural climate solutions really refer to three actions to help address climate change and increase the amount of carbon sequestered by nature. And we use the word natural climate solutions here. I'll tell you a little bit about the history of that. Number one, protecting intact ecosystems. Number two, restoring native ecosystems. And three, improving practices on working lands. And we funded a paper several years ago that formed a lot of the baseline and sort of got the, got that conversation started about natural climate solutions. So the Doris Duke Foundation Environment Program funded this natural climate solutions paper, which is really important because it showed where the error bars are. It showed like, okay, well, if we were to do reforestation, this is how much it would help climate change. And these are the uncertainties in it. So check out that paper, and there's a lot of subsequent papers on that. But when we looked at this and when we published it, so we're like, oh, well, we've done all this restoration, but we don't have a baseline like we do with energy. So we don't really understand how we can optimize it, right? So with the energy stuff, once we got the energy baseline, we were able to say, you know what uses the most fuel is the security truck. So why don't we electrify the security truck first? So we put our capital into, and adjusted our capital plans for vehicles and equipment, and we're able to replace that first to lower our carbon footprint as quickly as possible. Likewise, we have a Old Lord and Vernon Conservatory and an orchid greenhouse. And we've gone ahead and designed or in the process of designing an electric heating solution for that because it's natural gas now. That came up as our highest, user of natural gas. Surprise, surprise, because it's a greenhouse, right? And has an R value of like whatever, very low. So at any rate, we need to do this baseline, right, for our natural lands. And so what we've done is we work with Rutgers University right now, and the results are going to be coming out this year to create a carbon sequestration baseline. And just like with the energy stuff, we want this to be something that other institutions can use, right? So it's something that, we're learning from, and then maybe it can be applicable. Now, the stuff with the carbon sequestration is that it is going to be like very different in California or the Adirondacks, right? Like it depends sort of on the habitat types and soils and things like that. But we do believe we're learning stuff that can be applicable anywhere else. And, no matter what, we're going to have that baseline. So there's really like sort of three elements to this baseline we're doing with Rutgers. The first is field sampling and assessment elements, or measuring vegetation and soil carbon in different land use types. So on the top right there, you see what's called an eco-covariance tower. And what that does is it measures fluxes of gases over the years, so nitrous oxide and carbon dioxide, and that's one of our pasture lands that it's on. We also had it located in a wetland, and we have sap flow meters in the forest. So we're monitoring kind of flows of carbon to get that carbon baseline, because carbon, as you know, in ecosystems, it moves, right? So when trees die and degrade, carbon dioxide is released, or when, trees grow, it's absorbed. There's a scaling up element, so we're really looking at at how we scale this up to the region or to other folks, right? Like we'd really like to be able to use remote sensing, although it's not quite there, to say, hey, you have this forest and it is sequestering X amount of carbon dioxide, right? And be able to use GIS to kind of determine that within different ecoregions or habitat types or what have you. And then finally, we're linking the two together, right? So we have this institution where we get 200,000 visitors a year that are emitting all kinds of that's like our biggest emitter of carbon dioxide, actually. It's like the scope 3 emissions of visitors. But marrying that with this to kind of come up with that 2040 goal we have of being carbon negative, right? So we're doing a carbon footprint element. So, the energy analysis we did is really just operating carbon. So it's like what we burn in carbon every year. The carbon footprint analysis that Rutgers is doing for us is like a life cycle assessment. So it's taking into account things that you wouldn't necessarily take into account if you're just looking at the fuel you're burning. And so these will sort of all be melded together to help inform us as an institution of how we get to that carbon negative. Now, finally, I just want to talk about like moving forward a little bit and also realize, and I'd love to have a discussion about how, I realize we're sort of maybe at a bigger scale than some institutions, but I do think that there's roles for all institutions to do this, and really looking forward to the next presentations to learn about that. But overall, sort of natural climate solutions, here are some of the things I think moving forward that we're going to have to understand, right? So what are the most cost-effective and scalable natural climate solutions? I think scale up and scale down, right? We need more economic analysis to prioritize these efforts, right? So once we have the baseline, we can sort of optimize what the best efforts are. How can we improve monitoring and verification of carbon storage? This is key for ensuring the permanence and additionality of natural climate solutions. What policies and incentives and financing can be available? And then how do we balance natural climate solutions with other land use needs like food production and biodiversity conservation? So one of the things here, so Rutgers, they're great scientists. They came out here and they're looking at our grasslands, right? And at our cattle operation. And they're like, well, if you really want to be carbon negative, you should plant all those grasslands up in trees. And we're like, okay, but if we do that, all these endangered grassland birds are going to go away. And our mission is wildlife habitat, right? So I think that's what I was sort of talking about at the beginning, is there are these decisions we're going to have to make, right? Between kind of nature and biodiversity, and then how to maximize carbon dioxide. Now, what we're finding with the cows is that because our pastures have been so poorly managed in the past, and now we're going to sort of a rotational grazing system, we're actually able to increase the soil carbon content by our agricultural practices. So there is a maximum amount of soil that can be, or carbon that can be sequestered in the soil. So we feel like, cows are not necessarily the best things for climate change, as we know, but we think in this application, especially when degraded pasture lands like we have here, they can actually be positive if you sort of move them around. So at any rate, that's a real issue. It's like, that trade-off between biodiversity conservation and, working land use and natural climate solutions. And we're just going to have to, we have to study that more. And then finally, resiliency, right? Like how do we make sure that our natural climate solutions are resilient to that climate change we already see? Now, I think, you hear about like adaptation, risk management. Some of the things that are kind of controversial out there that we're exploring are things like assisted migration and things like that. So there's a whole element of things there too that I think could be scaled up or scaled down. So that's it. That's been, I think, about 15 minutes, and I'll turn it back over to Andrew. Thank you.
Excellent. Thank you so much, John. That's great. All right, for our second speaker, I'd like to turn it over to Nicole Selesky, who's the landscape supervisor at California Academy of Sciences in San Francisco, California. Nicole?
Hello, everyone. So happy to be here. And thank you, John, for that excellent presentation. I would love to visit sometime.
Well, anyone's welcome anytime. Just reach out to me.
Okay. So can everyone see my screen? Great. Okay. To give you an idea of we're only about 7+ acres, and we're inside of the Golden Gate Park, which is 20% larger than the New York City Central Park. So I'm giving this presentation on our living roof, which is 1 hectare or 2.5 acres. We are at the coast, so we're biodiverse. We're the largest wildlife corridor from Monterey Bay over to Marin, but it's man-made, so it should be technically a man-made wildlife corridor, but it still serves as such. So here's a picture of our program. We get them quite often and sometimes dual weekly. And we have lots of corporate events that help us take care of the roof. But all in all, it's minimal human traffic up there. And we have those windows up there that open and close for the rainforest below. The architect, Renzo Piano, thought, he scribbled on a little napkin and thought, lift up a piece of the park and put a building under it, and we'll echo the 7 domes of San Francisco on top of this building. So that's what they did in 2008. And green roofs really reduce the heat island effect. So cities are generally 7 degrees hotter than rural areas. So you really want to add as much greenery as possible in the cities, and green roofs are an easy way to do that. We have an extensive green roof, which means it's a very shallow soil profile. And this picture is native Clarkia seeds that we spread. So rewilding supports biodiversity. Here's a picture of one of our natives that spread on the lake ground cover. We irrigate the roof, and they love that irrigation. It's like a swamp marshland, Erythranthe guttata. We have minimal human interference on the roof. We create swaths of land without chemical use, and in 2008 we were deemed the largest LEED Platinum building in the world, but now that has changed. We've limited the VIP tour path to only 300 feet. So we also get lots of beautiful insects out there that would otherwise be scared away. We compost on site, several different areas on the roof, especially because we don't have an easy way to access the roof. It's only one public elevator. So that would be changed later. Let's see. So one of the nature-based solutions that we have done is really, we don't want to use electric 2-cycle engines or even electric ones. I'm sorry. We don't like the blowers eroding soil and chasing out the microorganisms or the nests of the wildlife. So it's really being mindful and being quiet for wildlife to get back to our cities. Let me see if this plays. These are some goldfinches eating the native Onithra alata seed heads, and they kind of gather around the seed pods like a spiral staircase. They're so into the gathering of seeds, you can walk right up to them. We also have the warblers as well. And this is a picture of some of our whale skulls. Whales will often die because of cargo ship hits. They'll wash up, and our mammalogy team will collect them and will bury them in the soil for years so the insects can eat the flesh, and then we'll put them in the sun so the sun can disinfect it. This is just to share with you one of the overlays of the irrigation system. It's pretty extensive and sophisticated, and that way we can alter every single little detail according mostly we alter it for events. That way the Academy can fundraise and have special events on the roof or different gardens, and I can alter that. Also, we are now switching from the well water pumped from, it used to be pumped from the windmills, but now it's just a big well from Ocean Beach in Golden Gate Park. And we're switching to reclaimed water, which is purple piped, not really fit for human consumption. We have endemic flora and fauna. on the roof. And one of the endemic plants we have is the Presidio clarkia. We also have to share with you the natives, more than 230 species of native plants. For instance, 200 native bee species. It's really special in our museum how we have all of these scientists working in the building. So it's like a classroom for all of those scientists to do studies. Another endemic that's really special is the Aristolochia californica, the Dutchman's pipe vine. This blue butterfly, the pipe vine swallowtail, and the beautiful caterpillar, that's their only host plant. So we'd like to create a safe place for the wildlife. As you can see, this really cute adolescent red-tailed hawk is in between the solar panels. By the way, we have 1 acre of solar panels on the roof. He's in the gutters between the solar panels and our roof. So we try to be quiet for him. PBS did an article of how it's really important to reduce the noise pollution, to bring back the ecosystem. And the health of the ecosystem also relies on reducing light pollution. So this, from internationaldarksky.org, this shows you from unacceptable light to best light, meaning off. But better, you can go to this option and add a cap to all your lights at night, so it only shines downward. This is a picture of 2 great horned owls. They're like 2 feet tall in our California live oak tree next to the roof. It's really cute, beautiful, and people will just gather, and it's like a tourist attraction. But they're quiet too. The people are very, very nice. So noxious invasive plant removal, this is definitely a really difficult thing to do when we use new chemicals and we rely sort of on intermittent corporate teams to remove them, or sometimes whenever we get money to add contractors for projects. This one on the top, oops, excuse me. That's the pampas grass. We have Earharta erecta, that's the worst one, and Rubus armeniacus. So one way to remove weeds is sheet mulching. I don't want to go too much into it. I think I'm over time, but you can refer back to this for instructions on sheet mulching. And then we have a hugelkultur mound. We use this often. You kind of collect some local wood, leaves, anything local from, you start really big in your mound and then you end up really small with the humus layer, not humus, but soil, whatever's local. So this is instructions on how to build it for later viewing. So one inspiration for a nature-based solution that we're doing here is the reimaginingsf.org. We have 35 organizations total signed up so far to, the goal is 30% of San Francisco is biodiverse green space by 2030. And this is this is the launch on the roof, and when all the heads of each organization came out and all of the news channels came to cover it. So finally, what we would change, we would add more berms and swales on the roof, because the roof has a problem with drainage. We have to clean out the drains manually. And we believe that the berms and swales would filter it. It would improve drainage, reducing runoff, adding robust root systems to filter water even more. So that would be great later for another roof. And then also what we have learned is we'd like to use local organic materials. We're moving away from monocultures. We're educating the public about acceptable horticulture and what it is to be a healthy ecosystem, discontinuing the practice of herbicides and insecticides, and planning for all season natives. And that is my presentation. Thank you so much to everyone who's watching. Please reach out to me, email me, and thank you so much to our presenters, the Wild Center, and up next is Duke Farms, or I'm sorry, up next is Wild Center in New York. Thanks.
Thank you so much, Nicole. That was really inspiring. I would love to visit sometime.
Good.
So for our final presentation, we'll be concluding with Phil Wagshaw, who's the facilities director at the Wild Center in Adirondack Park, New York. Phil?
I really appreciate it, Andrew. Thanks for the opportunity to share with everyone what we're doing at the Wild Center. And I look forward to kind of stimulating some thoughts. I think, you know, as we have participated in the climate toolkit, that's really what I've found is the ideas that come forth from the meetings and the toolkit have really helped formulate some of our directions as we look. So the Wild Center was established in 2006, and we were the first LEED certified museum in New York State, and the first LEED certified building in the Adirondack Park. So, you know, we have a long history of doing quote unquote green things. And so I was hoping to run through those to just give you a sense of where we are on the path. But also I wanted to talk to you a little bit about our youth climate summits, because this is one of the things that we do and we have done. And actually it's going on today at the Wild Center. That's why I'm coming to you from my house. We have 180 approximately youth from 25 school districts all across New York State that come to the Wild Center. This is the 13th edition of that. They come together, learn about climate solutions, learn about, and then they take them home. And part of the process that we go through is creating an action plan for those students. Whoops, let me go back here. There we go. Climate action plan, and basically that they develop an actionable plan to take home with them. Some of the students have started like a composting thing at their schools or a composting business. Some have put in water fountains. So this is one of those, for us, this is a huge event. We've actually held these in Sweden and Finland and Liberia and Sri Lanka. So I think, you know, it's amazing to me how we're able to have a global impact with these things. And the toolkit is available on our website. So please feel free to go and download that and have a youth climate summit. So I wanted to talk to you again about the path that we're on and some of the things that we've done. We established when we first built the Wild Center, again, back in 2007, 2008, we put solar panels on one of our buildings. We were early adopters for that. We also did a green roof, and I'm very jealous of Nicole's roof. But as you can see, we had a very limited space, as well as we have to get up there and weed and get the trees out. Because we have a lot of volunteers that find our roof. So another thing that we've done is we did domestic hot water for the museum using these solar panels. And it was originally put there for kitchen use, essentially. But with the size of the system, and with new developments in how we've decided to utilize it, we're actually going to use it for the reheat for our HVAC system, so that when we're air conditioning our air in the summer inside the museum, we'll be able to use this this water that comes off this system as reheat to take that dehumidified air and reheat it to reasonable levels as we go through our HVAC system. Another thing that we've done is we have eco pavers. 40% of our parking lot has eco pavers to allow for runoff. We installed a couple of years ago a large composter in a shipping container. This is about 40 feet long, 4 foot in diameter, and we compost all of our food waste on site. We also do some of our refuse from our gardening stuff. One of my team, his wife is a florist, so we get all the refuse from the florist and the local waste associated with that. And so in the falls, it's pumpkins, and through the winter, we keep this going. So we end up doing about 800 pounds a week, turning it into compost. We have a pellet boiler. This was a legacy issue that was thrown in my lap when I took over. And so in the shoulder seasons, we utilize it. We've been able to reduce our natural gas consumption dramatically. Over the last year, it's dropped 40%. So that's been a big plus for us. We've also installed a new building management system. Basically, we had a system that I had very little confidence in. And once we were able to get this system installed, we've been able to do a lot of different management things as far as like more scheduling of air handlers, reducing the time that things are running. We've been able to reduce our electrical usage between 10 and 15% at this point. And because this particular system is in a sense open source, we're able to manipulate it in a more granular fashion to really have a higher impact, and really customize it to the things that we want to do and to our building. For instance, in the Adirondacks, in the summer, we may have nights that are in the 40s. And so we'll be able to take this system and basically night flush the museum so that we can lower the temperature using ambient air, and then, lessen our air conditioning needs during the day. So all kinds of things. We've electrified tools, I think, and that was a good, from the toolkit. That was one of the things that we really got behind. Another thing that we're doing is a free cooler or a dry cooler. Basically, we have at the Wild Center, it's a natural history museum, but we also have animals there. We have a variety of live animals, but we have 12 different aquariums with about 42,000 gallons of water. And so because they are native Adirondack species, the water temperature typically is between 55 and 60 degrees. And so we have to chill our water year round for our aquariums. And through the course of the winter, it's quite expensive to run chillers to keep that water cold. And it's also it's very stressful on the equipment. And so we've had a lot of maintenance issues, and this will just run with ambient air once it gets below 40 degrees and chill the water. So I think that'll be a huge cost savings for us. We've also established a green team in the last year. This is us. This is the folks doing a waste audit. So we've really begun to embrace more and more as we go along. Okay, and then last summer, we opened the Climate Solutions exhibit, and I'll just kind of go through these photos. This exhibit really is talking about available climate solutions. We wanted to project, we wanted to build awareness, and we wanted to empower visitors and let them know that they had agency. And basically, we did that through stories by local people from the Adirondack region. And each one of these portraits represents someone local who is working on climate in some form or fashion, whether it's climate justice or it's on the food system or working with composting. There's an architect who is looking at embodied carbon in buildings. And so each one of these stories comes out through the exhibit and really brings home the solutions and really focuses on what visitors can do to engage with climate solutions and make a difference. So, and one of the core parts of the exhibit is this moss wall here on the right. This is moss that was harvested on our property. The campus is 115 acres. And we harvested the moss, we dyed it, and preserved it. And this is the outline of the Adirondack Park in small round twigs in the system. But basically, this is about carbon sequestration and about the role that the Adirondacks plays in sequestering carbon through the forest. And so, and this, as we look at nature-based solutions, my focus was really on the campus and carbon sequestration of the forest. And so this is our property. It's 115 acres, as I said, and the green area is forested. The highlighted green area, the rest of the area, we've got, of course, the rivers there. We also have some bog areas and some fen areas. But really the forest was my focus for the conversation today. And when we thought about maximizing carbon sequestration, and I will tell you that this is the beginning for me for this journey as we look at how we want to do this, how we approach this. And so when we think about the trees, the sequestration for the trees is really associated with the size of the tree species, and the health of the tree. And so our property, because it has been maintained as wild, we haven't done a lot of things with the property over time. The Adirondacks is, I think, one of the things about it that it's known for is the sections that are considered forever wild, where there's no trails, if you have to want to go there, you got to bushwhack. Nothing's done with the land. The land is set aside. Now our land is not quite that pristine. There were farms here, at the turn of the last century, and it also belonged to the school previous to us, so there were some trails through there, but it's been undisturbed for a number of years. And so the forest itself has grown and is pretty diverse. When we look at tree species, we've got primarily hemlock, beech, maple, and white pine. There are also there's various other species, but these are the primary tree species on the property. But when we look at tree health, and this has been my big concern, is we have each of the main tree species minus the maple are really struggling against a variety of diseases. This picture on the right here is a beech tree that has beech bark disease. And what will happen is this tree will grow to a certain size and the wind will come and it'll just snap off. And so we've got a lot of deadfall in the woods. We've got a lot of damage for trees in the woods. And it's actually quite distressing. So when we think about how we manage this forest and how we try to maximize carbon sequestration going forward and the things we want to think about, we also want to look at what climate change, what the impacts are going to be in the Northeast. And certainly, the temperature is going to go up. More intense and frequent storms, I think is key. I know that over the summer, it was, big in the news that, Montpelier, Vermont took a wicked hit. They got 9 inches of rain in 24 hours. These pictures here, this was 2011. And this was a fellow that was working in the facilities department. He's standing on the railing of this deck on the left. And you see where the water is, just it was actually on the top of the deck. And I was down there 2 days ago to take this picture, and the bottom of that deck is over 6 foot above the surface of the water. So we had 4 inches of rain over the course of 2 days. And we ended up with over 6 foot of water in this space. So we're just thinking about how the impacts of climate change are going to be on this particular area. My focus is really, how can I be a better steward of the property that we own? And so, in conclusion, these are the kinds of questions that I'm asking myself about the current conditions, the future conditions, what are the best species to meet the current conditions, and what'll thrive over the next 100 years? What if that is non-native? How does that impact things? We have a huge drive at the Wild Center to focus on native species. But with the beech disease and those kinds of things, what changes can we make? And what would the impact of any kind of species change beyond the animals and the plants that surround that? So, and again, we're starting down this path. It's easy for me from a facility standpoint to look at the things and say, well, I can reduce my electric bill. I can do that stuff. I can, lower my propane costs and reduce my carbon impact associated with those things. But this is the next step in my evolution and in my thought process. So, and that's it. Thank you. Thank you, Andrew.
Thank you so much, Phil. That was fantastic. All right, so it looks like we have a few minutes left for Q&A. So at this time, we'll open the floor up for questions and answers. You can feel free to use the Zoom chat function to enter any questions that you have for our speakers, and I will moderate beginning with any questions that are currently in the chat. So Phil, we had 2 questions come up immediately for what's going on at the Wild Center. So the first question is, what is the compost system that you use in the shipping container? And is it a rapid composter, sort of like the Rocket?
No, it's not. It's not a rapid composter. It usually takes 45 to 60 days from one end to the other. It's manufactured by a group in the Adirondacks called Compost for Good. And they have a series of these that they've prototyped, and we were one of the prototype sites. Basically, that large culvert sits in that shipping container, attached with a, you know, 3-phase motor that turns it, and it's at a slight angle. So as time goes on, the compost tumbles down and then, you know, is ejected out of the back end.
Awesome, thank you. And then second question for you, Phil, regarding the pavers. Do you find that you actually have to use mechanical maintenance on the vegetation, such as mowing or trimming, or does vehicular traffic keep that growth down? And do you find any areas are too compacted due to that vehicular traffic?
So I think, you know, what we've experienced is that the vehicular traffic does keep the vegetation down. I would recommend that you really focus on the installation of those pavers when you put them in. I think when they were originally put in, the fill within the pavers was not of the correct quality, so there's a lot of sand in there. The other issue is that because of the snowfall, the winter, those kinds of things, there was a lot of sand that got into the pavers as well. We've moved away from using sand as a non-slip device during winter, and we've gone to wood pellets basically to do that. So we're hopeful that over time, you know, they will come back and we'll get more growth within them.
Excellent. Thank you, Phil. All right, I have another question. This can be for anybody in the group. So it's clear that nature-based solutions can be applied across a wide range of sizes and scales. So what advice would you give for institutions, both small and large, who are just starting to look at implementing NBS on their campuses?
I can go. I mean, I think it all starts with the baseline, you know, and getting some accurate numbers about things. You know, along the lines that I think Phil is doing with the forest stuff. He is, you know, understanding kind of what you have first, and then from there you can kind of optimize your opportunities in a way, right? You could, you know, but without that sort of knowledge of what you have, I think that's the really, you know, that's kind of the important thing. And especially, you know, because we think about these systems differently than we did just 5 years ago. Like carbon really wasn't a thing, I would say, you know, as much, or natural climate solutions, or looking at carbon impacts. So even though a lot of us probably have really good baselines of, you know, for example, the tree species, you know, and the arboretums that we run or whatever, you know, converting that to sort of the natural, the carbon realm, I think is, you know, is kind of it was the best place for us to start. And I think, you know, regardless of your size, I think that's, you know, that's something you should start with.
That's perfect, John. Thank you. And so we'll wrap it up with one final question for the group. So many institutions understand that climate work needs to be prioritized as soon as possible. Yet it also seems fairly common for institutions to undergo a type of paralysis of action when looking to get started. So can you offer up any effective strategies for not only prioritizing, but also bringing to fruition nature-based solutions and climate positive projects?
I really think it has to do with engagement of stakeholders within the organization. I think that's really key. You know, we're motivated because, as being the Wild Center and being an educational institution, you know, as a natural history museum, we really want to walk the walk, eat our own dog food, basically, and make those changes. So there is, for our organization, there is some real support at the senior level, but also having the green team and having those folks that are engaged and excited about climate solutions, I think is critical. And, you get the right folks on the team and they'll be more than willing to execute.
I just wanted to add that it could also help looking at the project as a whole, like a Gaia, and treating it as a healthy environment. And the rule is 80-20. You want to have a healthy relationship. You look for positive reinforcements, positive 80% good, 20% bad. So having that allowance can help, and that can avoid greenwashing also. So when you're really looking at the holistic level, 80-20.
Like that, I would second both those comments. And just one of the things here at Duke Farms is we have people like Phil, like the facilities director, who is completely bought into these ideas. And I think that's brought us like so much more, so much benefit, and brought our plan forward. So that engaging of the stakeholders on staff and on our board has been great. So our facilities director, our motor pool coordinator, is like super into, even though he comes from like a race car background, internal combustion engine background, like super into electrification. So it is those key people really being bought in. I just to sort of kind of repeat what Phil said a little bit. I think that's been super helpful here at Duke Farms and at the Doris Duke Foundation.
Excellent. Really fantastic. Thank you guys so much. I want to thank everybody for attending this Climate Toolkit webinar, and a very special thanks to John, Nicole, and Phil for joining us today and sharing the amazing work happening at your institutions. If you have any additional questions, please reach out to me via email. I'll place my email in the chat right now. I would love to hear from you. And I will relay any questions that you have to our speakers. Just a final note, a recording of this webinar will be made available to share with others. We'll be sending that link to you in the coming week. In the meantime, I hope you all have safe and happy holidays, and we look forward to connecting with you again in 2024. So thank you and have a wonderful rest of your day.